Hi everybody, today we're going to be discussing the AP Chemistry 2018 FRQ number 3, which talks about titration, ion properties, and a little bit of stoichiometry and lab technique. For this question, you have to remember that when a transition metal is ionized, the s sublevel electrons pop off first. Therefore, our full electron configuration would be 1s2, 2s2, 2p6, 3s2, and 3d6 because we have no 4s2 anymore. While the iron 2 ion and iron 3 ion have the same number of sublevels, you must explain that because there are more electrons in the iron 2 ion, there is increased electron-to-electron repulsion, so the radius of the iron 2 ion is larger for this reason. Coulombs' law is dictated by two factors, distance and magnitude of charge. Here, the most glaring difference is the magnitude of charge. Since iron 3 has a greater magnitude of charge, it is more attracted to the water molecules according to Coulombs' law. This is just a simple redox half reaction. We take our original species, iron 2+, and change it into iron 3. So, since we lose a charge, we also have to lose an electron, and we put it on the product side. Here, we just have to convert from the original potassium permanganate solution to moles of iron. Then, we can divide by the original volume of the iron 2 solution to get our final molarity, 0.306. Remember that a volumetric flask has one marking, the volume for which it is designated. We are given a 25.00 milliliter volumetric flask. Therefore, it is inaccurate to measure 10 milliliters since it only has one marking for 25 milliliters. This part is just some simple stoichiometry. We take our grams of iron 3 oxide and we convert to moles, and we take that mole and use our mole ratio to convert to moles of iron. Since there are 2 moles of iron per 1 mole of iron 3 oxide, we use that ratio. Now that we have our moles of iron from the last question, we can convert that to grams and divide by the original grams sample to get our purity of our iron. Make sure you are dividing by the 6.724 grams, not the iron 3 oxide produced. This question asks us whether if we have some iron 2 oxide in our product, how would that affect the actual mass percent that we got in the last question? Well, it would actually be lower because if you take a sample that contains any iron 2 oxide rather than completely being iron 3 oxide, it will have an actual higher mass percent of iron because in iron 2 oxide, the mass percent of iron is higher than in iron 3 oxide. And it will have a higher mass percent than if it were just pure iron 3 oxide. Therefore, when you calculate the moles of iron and also by extension the mass percent of iron, you'll get a lower answer. That's all I have for y'all today. Thanks for watching, and I'll see you guys in the next video.